Hello. In this video, we're going to look at the basic trig graphs, what they look like. And as usual, we'll start off by just looking at the basic functions, the equations that we would have. So for the different types of graph, we're going to look at y is equal to sine x, y is equal to cos x, and y is equal to tan x. Now, in all the other graphs we've done so far, we've always set up a table of values. So I'm going to do the same here. I'll go and I'm just going to deal with a sine graph to begin with. So I've got it in my table form. I go and press sine of x, press execute, select the graph that I want and go to the table function. Now, the table has been defined and it's going from 0 to 1 to 3, 4. There doesn't seem to be much movement that's happening there. Now, x is the number of degrees because sine, cos, and tan are ratios that work with angle degrees. So we need to actually think how many degrees we're going to be working with. And in fact, our scale needs to be reset quite dramatically. We're going to start at 0 and we're going to go through to 360 degrees because that will give us a full revolution. That's not 360 degrees, 360 degrees. And the steps that we're going to take, rather than doing one step at a time, I'm just going to do in jumps of 10 degrees and have a look at what we're going to get there. So we've got our table of values and you will see that we start to get these numbers starting at 0 and increasing up. They go up as far as 1 and then they start to come down again and they continue through and then they start to go negative. They go down as low as -1 and then they start to come up again. So there's a lot of points here, 36 in all, and I'm not going to plot each one of those separately. I'm just going to go straight to a graph of this and see what this looks like. Well, there is the graph of the sine function been drawn. It goes through this curve, starts off 0, 0. It increases up till it reaches its maximum point over here at 90 degrees of 1. And after that, it drops down again until it gets back down to 0 at 180 degrees. After 180 degrees, it continues to drop down all the way down to its lowest value over here of -1 when I'm on 270 degrees. And then it rises up again to 360 degrees where the value of y is 0. Now the graph is quite special because it's symmetrical. It's symmetrical between 0 and 180 degrees. So that's a nice U curve that we've got over there. But it's also symmetrical from 180 degrees through to 360 degrees. So we can see values over here and here that match each other. This one is at -0.5 and it's 30 degrees away from 180 from where it started. This one is also at -0.5 and that's at 330 degrees, also 30 degrees from where we finished. So it's a symmetrical graph and it follows this periodic pattern like a sound wave. So that's what the sine graph looks like. Now the cos graph looks similar to this. Here it is in green, but it just seems to be out of phase. So instead of starting at 0, it starts at 1. Instead of rising up to 1, it drops down to 0, and in fact drops all the way down to -1, just like the sine one does, but it's 90 degrees out. So there's a difference here between these two graphs. So the cos curve looks very similar to the sine curve, but it's just happening at different angles, different times. But it follows the same basic curve, has a maximum of 1, a minimum of -1, going between 0 degrees and 360 degrees. The last one that we're going to put there is the tan graph, and this one is significantly different. This one starts off at 0 and then it suddenly rises quite quickly, quite swiftly, until it reaches a point which I can't really see on the graph at this stage. If I try zooming out, it would appear to be approaching this line that runs over here. And I remember we've used this term before of an asymptote. So it seems to be an asymptote on this line over here. That line is where the cos graph crosses through the x-axis, and that's on 90 degrees. So there seems to be an asymptote over here for the trig graph on 90 degrees. And the graph, the yellow graph here, is approaching it as well when you go down towards 90 from 150. There also seems to be another asymptote that appears to lie around about the 270 degree mark. That's not too surprising because that's a multiple of 90. So 180 degrees on from 90, I get to 270, and that's where the next asymptote occurs. So we've got three graphs here, two that look fairly similar, the third one which looks quite different, and that is what the trig graphs look like. So if I just insert a copy that I made of that picture. No, I don't want this to happen here now. Let's just close that down. There's the image that I've put in, and I just need to move it around slightly. And so here are different graphs. This one is y is equal to, actually let's do it in the right colors. This one is y is equal to sine x. This one is y is equal to cos x. And do I have a yellow color here? Orangey color, yeah. This is y is equal to tan x. Now, they're a bit different to draw because we have to work with degrees. But again, you might come across this and see this particular curve and might want to use it at a later stage. Hope this helps to give you a basic idea of what the trig graphs look like. We will have a later video that shows how these graphs can get transformed in different ways. Goodbye.